Hello everyone, and welcome to another video in my channel. In this video, we are given x over x plus 1 as a quantity raised to power 2 plus x over x minus 1 as a different quantity raised to power 2 is equal to 12. Before I proceed, I would like you to do me a favor. Please, I need you to like this video, whether you find it interesting or not, and also subscribe to my channel if you haven't done so. Then I would like you to share this video. Now let's go straight to this question. What do we know about this question? We see that the left hand side of the equation comprises of basically two squares whose sum is equal to 12. Now the question is, do we have two integers whose squares will sum up to 12? I don't think so. But if there is, I would like to read the answer in the comment section. Now, do we also notice that the denominators of the fractions are conjugates? I don't know if this information is useful, but it is worth mentioning. Now, what we are going to do is to use algebraic method to solve this problem. We are going to let this be equal to b and this be equal to a. If that's the case, a squared plus b squared is equal to 12. Now, we can't solve this problem like this, so we have to rewrite this expression. If I have a plus b raised to power 2 minus 2ab, it will be equal to a squared plus b squared. So that means I am going to express these terms in brackets in this form. That becomes x over x plus 1, that is for a, plus x over x minus 1, all raised to power 2, according to this part, minus 2 times x over x plus 1 times x over x minus 1 is equal to 12. And let us simplify further. In these brackets, we have difference of two squares, x squared minus 1. This divided by this will remain this. So we have x times x minus 1. And this divided by this will remain this, plus x times x plus 1 all raised to power 2 minus 2 times x is x squared, and we'll have x squared minus 1. Let's remember that this is difference of two squares is equal to 12. If we open this bracket, we have x squared, this times this, minus x plus x times x is x squared, then plus x all over x squared minus 1. Let's remember all of them is raised to power 2. Then minus 2x squared over x squared minus 1 is equal to 12. This and this will cancel out. This and this will give us 2x squared over x squared minus 1, all raised to power 2, minus 2x squared over x squared minus 1 equals to 12. Now, do you notice that this is a quadratic equation? Yes. So we are going to let this be equal to y squared and this be equal to y. So I have minus y here is equal to 12. And do you also notice that this quadratic equation can be factorized? That makes our work easier. Now let's factorize this quadratic equation. We'll have y squared minus 4y plus 3y. Minus 4y plus 3y will give us minus y. Then minus 12 is equal to 0. If I group them, y is common in the first bracket, remaining y minus 4. And plus 3 is common in the second bracket, remaining y minus 4 equals to 0. So y minus 4 and y plus 3 is equal to 0. That makes y is equal to 4 or y is equal to minus 3. Now let us now use 2x squared over x squared minus 1 for y. Then after that, when we get the value of x, we'll back substitute to see if we're going to get 12. So when y is equal to 4, that means 2x squared over x squared minus 1 is equal to 4. If I cross multiply, 2x squared is equal to 4x squared minus 1, and 2x squared is equal to 4x squared minus 4. Then 2x squared, if I bring this one here, is equal to 4. x squared is equal to 2 and x is equal to plus or minus root 2. So x is equal to plus root 2 or x is equal to minus root 2. Before we back substitute, let us first of all find the value of x when y is minus 3. And I'm going to do it up here. So we are saying y is equal to minus 3, and then y is x squared, y is 2x squared rather, over x squared minus 1 is equal to minus 3. Now 2x squared equals to minus 3 times x squared minus 1 if I cross multiply. Then 2x squared is equal to minus 3x squared plus 3. Then 5x squared, if I bring this one here, is equal to 3. That simply means x squared is equal to 3 over 5. Or x is equal to plus or minus the root of 3 over the root of 5. Or plus or minus root 3 over root 5. I can rewrite this one as root 5 over root 5, which is plus or minus root 15 over 5. That is my x. And let us see if our answers are correct. I'm going to only use x is equal to plus root 2 to test whether the solutions are correct. Then you can try these other ones when x is minus 2 and when x is plus or minus root 15 over 5 at your own leisure. So I have x over x plus 1 squared plus x over x minus 1 squared is equal to 12. Let's put in root 2 for x. So root 2 over root 2 plus 1 all squared plus root 2 over root 2 minus 1 all squared is equal to 12. So here is 2 over 2 plus 2 root 2 plus 1 and plus 2 over 2 minus 2 root 2 plus 1. If I open these brackets, then equals to 12. So 2 over 3 plus 2 root 2 plus 2 over 3 minus 2 root 2 equals to 12. The conjugate of this is 3 minus 2 root 2. So 2 over 3 plus 2 root 2 times 3 minus 2 root 2 over 3 minus 2 root 2 plus the conjugate of this is also this 3 plus 2 root 2. So I have 2 over 3 minus 2 root 2 times 3 plus 2 root 2 over 3 plus 2 root 2 is equal to 12. So this is 6 minus 4 root 2 and this is 9 minus 8 plus 6 plus 4 root 2 over 9 minus 8 is equal to 12. 9 minus 8 is 1. Yes, this and this will cancel out, remaining 6 plus 6, giving us 12. So our answer is correct.